In this video, we're going to discuss how to use a problem-solving strategy or different types of problem-solving strategies for story problems. So our overall goal with this, and a lot of story problems in general, is to take a story problem and turn it into a mechanical problem, similar to something we've seen in our Chapter 2 material, and then solve it using those methods. Now, unfortunately, this is a big one that I'm going to rip the band-aid off now. There is no universal this always works method or strategy for all story problems. I am not aware of one that does exist, and if it did exist, all of the world's problems would be fixed. But fortunately, that isn't the case. So what we want to do is we want to create and develop and continuously revise our own strategy or strategies that will come up. So as we go through 3 examples today, you are going to be welcome to use any of those that you would like for different story problems. Maybe you want to mix and match some of those processes that we did or didn't do in these problems. Maybe you've seen something else online that you really like that you want to integrate into your process, whatever you'd like to use. But you do want to make sure that you have one, you're developing one, and you're continuously revising it. And the revising it is not because necessarily your method is wrong, but because each problem is a little bit different, a little bit unique, and maybe we need to modify that from one problem to another. And what we're going to also take a look at is an English to Algebra document that's over here just to the right of this one that we're looking at right now. And I think that's very helpful to go through and translate things from English statements into algebraic expressions. To the point, do not rush this process for converting and translating story problems into mechanical problems. A lot of people will want to read something once really fast and then just start writing things down and get to an answer really quickly versus the correct answer in a reasonable manner. So start off slow with these. As we start to get used to patterns of English phrases and whatnot, then we can start to slowly speed up and get faster with it from there. But these aren't easy. Story problems are generally the biggest headaches that a lot of people have, so take it slow, take it steady as necessary. So let's jump over here right next to this and take a look at this English to Algebra page. I'd recommend, as necessary, pausing the video and either screenshotting this or writing it down for yourself as necessary, but this is not all of them, but it's some of the ways that we can see things written out in English and how we can translate that into algebraic statements. It should be stated with all of these as well, the order in which we write these things in, the A and the B, N and M, number and something else, the order does matter with these. We have a couple of these operations, like addition and multiplication, where we can get away in some instances with reversing the orders, but I would not get into the habit of applying that to all operations because we get to subtraction problems and division problems and we see that the order absolutely does matter. And if you're in the boat of thinking, well, no it doesn't, I can put it in any order that I want, I'd like you to take a look at these 2 examples that we have right here, 10 minus m and m minus 10. Notice that the way it's written in English, there's only a 1-word difference between them, but that changes a lot with this. And if you're wondering, well, that doesn't really seem like it changes a whole lot with it, then here's my question to you. Make this m 10 million and put some dollar signs in front of this. So 10 minus $10 million. $10 million minus $10. Which one would you rather have in your bank account? And suddenly, hopefully, the order, which one we pick, absolutely does matter. We want the 10 million minus $10 versus 10 minus $10 million, right? So the order we write these things in, especially with subtraction showing up, absolutely matters. Do not rush that because that is something that gets a lot of people on homeworks, tests, story problems in general. So we have some other ones here for multiplication and division. Again, kind of our main buzzwords listed up here and some examples of how that can be written out right next to that. Same thing with division listed off right here. We do have another page with some bit more division stuff showing up and a little bit more working with powers. Powers is also referred to as exponents with this, so something to the second power, third power, fourth power, things like this. Now, one that I find highly important and also very, very, very useful for breaking down big long paragraphs and big long sentences of stuff are which buzzwords correspond with equals, or the equal sign in here. So we have a list of these that I would again recommend pausing the video and writing down for yourself as necessary. The great part about identifying these buzzwords that mean the equal sign is we can effectively split up a sentence or split up a paragraph to being everything on the left side of the equal sign and everything on the right side of the equal sign. So keep an eye out for these buzzwords as we are going through these problems, because this is going to help break things down into smaller, probably more manageable parts and make translating these things a lot easier. The last ones we have multiplication by 2 showing up in here, some different ways that can be denoted. Multiplying by 1/2 or dividing by 2, as we see with a couple of examples written in right here. So a few ways that can be written out. Then we have some ways that geometry problems and some word problems can have relationships between numbers written out here. Pay attention specifically to this consecutive integer one. If we have, let's say, 3 consecutive integers versus 3 consecutive odd or even integers, how we write those out, how we could use this to help translate things into expressions and equations for ourselves. But just a quick summary of a lot of these here. Again, as necessary, pause the video, go back and review these, write them down for yourself, maybe screenshot the video as necessary. But we are going to use these as we dive into 3 example problems. Our first story problem that we have here is asking us and telling us the difference of a number and 8 is 4. Find the number. Well, employing some of the strategies or potential strategies that we could be using, I think it's good to identify what buzzwords are and aren't showing up in this problem, and either circle, highlight, underline those to make them stand out to you. As I'm reading through this, I'm noticing we have the buzzword is showing up. We really like this one because this denotes an equal sign. So if you want to underline that, you could. Some people like to instead go and box buzzwords like this. You do whatever works best for you. I'm going to go ahead and just underline it. Now the buzzword is corresponds with an equal sign. So that means that something equals something else. Down below in this space here, I can start building little bits and pieces of my overall equation as I'm going through and reading through this thing. So I have something equals something else. Doesn't seem like much, but hey, at least it's something. Now everything to the left of this buzzword is going to be the left side of this equation. Everything to the right of this buzzword is going to be the right side of this equation because that's my equal sign. Now we can either do the left side or the right side first. It really doesn't matter, but we just need to pick one and commit to it. I'm going to do the right side first because we're told stuff is 4. So I should have something equals 4 on this right hand side. So there we go. Half of this thing is already written out for us. Now we need to just make sense of this other half. And we can ignore everything else at this point in time. So the difference of a number and 8. Well, the word difference corresponds with subtraction. So I'm going to have something minus something else. So I'm just bringing this and writing a subtraction sign here for myself. So the difference of a number and 8. So is this going to be the number minus 8, or is it going to be 8 minus our number? Well, if we take a look at the English to Algebra page that we previously were taking a look at, maybe you screenshotted it or wrote some of those down. In the subtraction section, we have it written out as the difference between x and 7. That's what's listed on the paper there. And the way that it's listed from left to right is exactly how it's going to be written left to right. So in this case, with this buzzword for subtraction, we can do x minus 8. Now again, depending on the wording, depending on the phrasing of the problem, this is not always going to be exactly as it's read left to right. So keep an eye out and always check back to that English to Algebra page if you need that. So let's check this thing before we actually go through and solve it, because if we have the wrong setup, it doesn't matter what we do, everything else we do afterwards is going to give us a wrong answer. So the difference of a number and 8, okay, so that number minus 8, that's the difference between those. Okay, that looks good. Is 4. Should be equaling 4. Okay, that looks good also. Find the numbers. We're trying to find out what this number is over here. So this all looks great in terms of our setup. We've translated it correctly. Now we can pretty much ignore this entire set of stuff up here and just focus on actually solving this thing. We don't actually want to completely ignore it, but we just now focus in on just doing math. So let's solve this thing. I'm going to add 8 to both sides. I'm going to get x is equal to 12. If we want to go through and check this, we could either do it mentally or plugging things in. Okay, well, 8, I guess not 8, 12 minus 8, that's going to be 4. 4 is equal to 4. Great, so we have the right answer here. Looking at our second example, we're told to find 3 consecutive odd numbers whose sum is 291. So we're going to use a slightly different method than we used in the first problem, just to see some different ways that we can think on these things and organize these for ourselves as we're going through and setting them up. Buzzwords are still something that we want to be on the lookout for, so don't stop looking for those depending on the strategy that you're going to use for organizing these things. They're still very useful. And once again, we have the buzzword is showing up in here. So that's going to tell us that something is equal to something else. So again, I'm going to go ahead and write in my equal sign. That tells me I have the left side of this sentence to work with and the right side to work with. And I can do either side of that as I see fit. I'm going to do the right side again because we should have something equaling 291. Kind of nice, we have half this thing done. Something equals 291. Fantastic. Now there's the left side. It's going to be a little tricky, but we're told find 3 consecutive odd numbers whose sum is 291. Okay, so let's start with this in a super generalized sense. We have 3 numbers who are adding together. The sum means addition. Make a little note that there. So I'm going to have, this is some ways that I've seen people do this, I'm going to have something plus something else plus something else. So I have 3 consecutive odd numbers, or just 3 numbers whose sum is 291. I've got something here, I've got something here, and I've got something here. So I have 3 things adding together to equal 291. We're not done with this, but at the very least, this just gives us a framework of seeing, hey, I can start with something generalized, and now I'm going to reread this thing, and I'm going to revise this a little bit more in my next read through. It may be a little bit more still, and a little bit more still after that. There's nothing wrong with doing that, and I would really recommend embracing that and trying that a few times with story problems that you see on the homework or in your classes. Let's revise this a little bit more specifically. Okay, I want 3 consecutive odd numbers. So off to the side here, if we're thinking on consecutive odd numbers, I'm going to do this in green. Let's say I had my first odd number was the number 5. Well, the next consecutive odd number would be 7, and then the next one would be 9. Okay, there's got to be a pattern that's showing up there. Let's try another set of numbers. What if we did, I don't know, let's do 23. 23, 25, and then 27. So what are we noticing about these? Well, from one number to the next, I'm increasing by 2. From that number to the next one, I'm increasing by yet another 2. The same pattern holds up here. So if I have my first number, x, I don't know what that is, but that could be my first odd number. We will assume that it's odd. The next odd number would be this x plus 2, because it's 2 more than that. And then what would the final one be? Well, it would be this number plus another 2. Well, 2 plus 2 is going to give me 4, so I'm going to have x plus 4. And we can see this nice little pattern that shows up right here. So let's bring this into our equation. We can say I have my first number, x, plus my second number, which is x plus 2, plus my third number, which is x plus 4, and those all add together to equal 291. And suddenly, there we go. We actually have an equation written out for ourselves. We had something initially, we did some thinking off to the side here, and then we revised it, and now we have our equation. Absolutely nothing wrong with this. I would really recommend that we lean into this strategy, because I think this is a very helpful one for a lot of more advanced problems. So now we can just focus in on solving this thing. Let me simplify this left side down as best I possibly can and combine like terms. I have the x's adding together. That's going to give me 3x. I have 2 and 4 adding together. That's going to give me 6. So I have 3x plus 6 is equal to 291. So in solving this thing, I need to find my x value. I'm going to subtract 6 from both sides. And I'm going to get 3x is equal to 285. I want to get the x all by itself, so I'm going to divide both sides by 3. And I'm getting that x is equal to 95. Now, we aren't done here. Yes, we found our x value. Great. But we're told to find 3 consecutive odd numbers. So I have my first one. I need to find out what these other 2 are. And thankfully, we have a little bit of a strategy and a little bit of a setup for that. So my first number is going to be 95. The next one is going to be 95 plus 2. That's going to give me 97. And then my last number is going to be 95 plus 4, which is going to give me 99. So what are my 3 consecutive odd numbers? Well, it's going to be 95, 97, and 99. So writing out a general thing for ourselves, really we didn't do any math with this first one. We just made some boxes to represent numbers, and then we specified them and revised that a little bit more to make the equation afterwards. We really recommend leaning into doing something like this with a lot of these more advanced problems, where we have more specific and kind of weird things going on with each individual number. I think it's very helpful with a lot of these. So give this a try on some of your problems that you're going through. Bringing things together for our third and final example, we are told one number is 11 less than another. If their sum is increased by 8, the result is 71. Find the 2 numbers. So we've got a lot that's going on in this particular problem. We have some information about these 2 numbers, something about the relationship between them. We also know that they're interacting in some other way and some other stuff is adding on to them. And then we're getting some result from that. We're trying to find what these 2 numbers are. So again, I recommend taking these things in small controlled parts. Look for buzzwords that stand out to us to tell us something that's going on with this problem. So we can choose the first sentence or the second one. The second one sounds like it gives us the general idea of what's going on in the overall problem. So let's start with the second sentence, because why not? So some buzzwords that are standing out in here, we've got is. We've got is again. We've got sum. So the sum is, okay, so things are adding together. And then we have some other things that are resulting in something else. So I'm going to go ahead and underline is. Or we have really the result is, we have the sum, and then increased or increased by. So we have some interesting things going on here. So we have something equals something, looks like 71. So stuff equals 71. Well, what is the rest of this stuff? It looks like if their sum which sounds like it's two numbers here. So the sum of these two numbers, whatever they are, and whatever that sum is increased by 8. That sounds like it's going to be addition. So I'm going to have addition showing up between the numbers, and I'm going to also be adding on an additional 8 here as well. So let's make a little display for ourselves. So we've got our first number. We're adding that with our second number. We have a sum here. So if their sum, these two numbers' sum, is increased by 8. Okay, so these things are adding together. That's the sum there. Whatever this result is increased by 8, meaning I'm adding 8 on top of this. The result is 71. Okay, well that seems reasonable with this setup here. I don't have enough to set up an equation for myself and have it done yet, but I at least know some number plus a different number equals 8. Should also be stated here, I cannot simply fill this in with x and x. I don't know if these numbers are the same or different, or how they are the different from one another. We need some additional information in this problem to help us specify what's going to go inside these boxes. Thankfully, we do have another sentence here that tells us some information about these two numbers. We're told one number is, buzzword again, 11 less than another. This less than is another buzzword. That means we're going to have subtraction showing up. So we have something equals and then some subtraction showing up here. I'm going to do this sentence over off to the side over in this area here. Kind of separate this out a little bit for ourselves. So I'm going to have something, one number is, and then 11 less than another, so I have a subtraction showing up. Now, one number, I don't know what this number is. It could be 1, it could be -3, it could be +50. I have no clue what this is. So we get to label this as an unknown or a variable of our choosing. I'm going to go ahead and choose x for this. So one number, whatever it is, we'll call it x, is equal to 11 less than another. So again, with subtraction, we need to determine what's the order that this is going to be written in. Is it going to be 11 minus a number, or is it going to be a number minus 11? We could think of this also as in a different way of saying, am I taking 11 away from a number, or am I taking some number away from 11? Well, this is actually going to be the case where I'm taking 11 away from a number. So the way it's written in English versus the way it translates algebraically is reversed. This is also something that's written in on that English to Algebra page that we went through at the very start of the video. I'd recommend going back and taking a look at this, because there is a difference between this being less than, or 11 less than another, and 11 less another. It's very subtle, it's very frustrating, no arguments there, but the ordering that we have with that absolutely does matter. So, now that we're working with this, we have some information about these two numbers. We could start specifying this a little bit more directly and say, okay, well, I have my first number, x, plus my second number, y, plus 8 is equal to 71. This is a little bit more specific than what we had previously, which is good. However, I have one equation and two unknowns. It is impossible for me, you, or anyone to solve one equation with two unknowns, two variables in it, and get a single number answer. I need to rewrite either this y or this x to be in terms of the other variable. Meaning I want all of these to be x's, or I want all of these to be y's. Over here, it's actually kind of nice. We have x in terms of y. We know x is the same as y minus 11. So over in this side, I can rewrite this x instead of being x, I can make it y minus 11 plus y plus 8 equals 71. And suddenly, I now have a single equation with one variable in it, and now I can solve this thing and find out what y is. So keep that in mind as you're going through these problems. Similar to what we did with number 2, I started with an equation, I revised it, we wrote out some other information based on what the problem tells us, and I revised that equation one more time, and now I have something that I can solve. There's absolutely nothing wrong with doing that as you're going through these problems, and again, I recommend that we embrace that strategy. That goes a long way for us. So now I can just combine things together on this left side over here. I get 2y minus 3 equals 71. I'm going to go ahead and add 3 to both sides. And I'm going to be getting 2y is equal to 74. I'm going to divide both sides by 2. And I'm going to be getting y is equal to 37. So fantastic. We have one of our two numbers. We are told to find the two numbers. We have one of them. We have our y value, but now I need to find out what is x. We have two choices here. We can either plug this y back into this equation and then solve for x, or we can plug this 37 into this equation that we have right here, and this is going to tell us x also. Let's use this one on the right just for the sake of seeing a different way of writing this out. So I'm going to have x is equal to 37 minus 11. I'm getting x is equal to 26. So what are my two numbers for this problem? I'm going to have x is 26 and y is 37. So as a quick recap of what we covered in our video today, we went through a couple different ways that we can write out and set up and solve some story problems by turning them into mechanical problems. Again, any and all methods and ways that we wrote this out and visualize this, you can create and develop and continuously revise as you see fit. There is no universal this always works method or strategy for story problems. So if you saw things you really liked in the methods that we used today, you're more than welcome to use those. If you want to modify how you organize it for yourself, hey, go for it, make that happen, do it. Try some different things out. Biggest thing is to not rush the process of converting or translating story problems into mechanical problems. Take that time as necessary to rewrite English into algebra by reviewing the note sheet that we had, the different processes and different wording and ordering that we have these numbers and variables in. We had our 3 example problems listed out here, the difference between a number and 8, finding 3 consecutive numbers, and then finding 2 numbers with some weird stuff where we have a relationship between those 2 numbers as well. We also had our English to algebra translations here. I'm going to put those up one more time so you can go ahead and write those out for yourself if you need to. Again, I'd pause the video as necessary to write this stuff down for yourself. Remember that the order does matter with how we set these things up. If we get them in the wrong order, a lot of these problems can fall apart for us, and we would really like to avoid that if we can help it. Especially be on the lookout for the equal sign buzzwords. These are really, 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 really important. I think they make translating problems a lot easier, and that we can break things down into smaller parts from there. We had some other parts with multiplying by 2 or multiplying by 1/2 or dividing by 2. Then we have a couple parts here with some geometry problems. We didn't see as many of these, but we covered those in some later sections, or maybe you'll see them on your homework. And then some word problem relationships, and having consecutive integers, consecutive numbers, and things like this as well. Now last but not least, I'm going to go over and give us some story problems to work on as well. If you'd like to pause the video here, try some of these for yourself, I'd recommend doing so. We'll scroll down and take a look at the final answers for each of these as well. So hopefully you're trying a couple of these strategies. Hopefully you see what does and doesn't work for you with these problems and give this a bit of a try on your own problems here. But that's everything for the 3.1 material.